So climate change is already an alarming topic. Yes, we know this. And I would argue that tipping points is probably one of the most alarming parts of climate change. So I wanted to kind of break down a little bit what those tipping points are and what are particular ones that we need to be looking at. It was a lot of research, surprisingly, because I actually found an article that laid out beautifully overall the tipping points that I need to talk about. And so I was like, okay, we got this, easy. But then I forgot, oh my goodness, this is a lot of science, a lot to break down, and so I guess let's get right into it. Hey y'all, it's Becky here from the Beckisphere, and welcome back to my channel. If you're new here, hi, my name is Becky, and every Tuesday now, and Thursday, we talk about the climate here. The problems, yes, but the solutions, yes. So if that sounds like something you would be interested in, go ahead and click that subscribe button below, hit the like, comment, share, all that good stuff. And today we are going to talk about climate tipping points. I'm going to try to simplify each of these tipping points as much as I can, but keep in mind, the world is complicated. There's a reason why people study for decades on one particular element of the overall global system, because it's a lot, and it's a lot to predict too. There's so many moving factors, and that's something you're going to see for sure within this list. But before I get into it, what are tipping points? Tipping points are thresholds where a tiny change could push a system into a completely new state. Tipping points are not unique to talking about like climate change. Tipping points are a pretty common term for a lot of different studies. But it first became more of a popular term in the 2000s when a book called Tipping Points was released to the general public. After that, there ended up being a huge surge in the amount of scientific papers that talk about tipping points. So that's kind of why we started hearing a lot more about it starting in the 2000s. But that can make it further confusing because in addition to having that new term being more readily used, we were also discussing the whole difference between global warming and climate change as terms, and there was more pushback from certain political parties about the validity of climate change in general. And so unfortunately, I think that the tipping point thing ended up being used as more of an alarmist sort of terminology for those who did not want to accept climate change was happening to look at and be like, oh, these people are overreacting, and look at these tipping points. None of them have happened, right? We'll talk about it. When discussing climate change in particular, the term first came up in the 80s by Professor Wally Brooker of the Columbia University. And he said, Earth's climate does not respond to forcing in a smooth and gradual way. Rather, it responds in sharp jumps, which involve large-scale reorganization of Earth's system. So that was kind of his descriptor for what tipping points were. And it really shows that, in fact, instead of it being more of a linear progression, we are finding that the Earth is warming and the results are happening in more of an exponential pattern. And the difficulty with tipping points is because there are so many variables that scientists need to look at in order to determine the best way to model certain behaviors in the global system, it can be difficult for them to put a particular temperature amount, like this amount of warming will result in this. And it's also difficult for scientists to put a specific timeline to when this event is supposed to happen. For example, scientists are actually finding that certain parts of the globe are melting a lot faster than they initially thought because there were certain variables that they didn't think to keep in mind. So you'll begin to see some of the more complicated factors that play into certain melting in different areas. And that's where we're going to start with the first set of tipping points. So I'm taking this from a Carbon Brief article that was published, I think, in October of last year, so pretty relatively new, and they covered 9 different tipping points that we need to look out for as the Earth continues to warm. And within those tipping points, there are 3 main categories of the tipping points. One is melting, so what areas are we expecting to melt and create a positive feedback loop, which is something happens and that results in the effect becoming bigger and bigger and bigger. So it's like positive for the effect, not necessarily positive as in good. But yeah, so there are positive feedback loops that result in more melting to occur faster, hence again that exponential curve. We're also going to be talking about biome shifts, and biome are basically just different areas in which certain ecosystems are found. So we'll talk more about that. And then the third method of tipping, or the third category of tipping points, is circulatory shifts. And so that has to do with either oceanic or atmospheric changes in the globe, which will then impact where warm and cold air go in different parts of the world. So it will impact regional climate a lot. So without further ado, let's start with the first one, which is melting. So the first area that we are going to look at for a potential tipping point is the Greenland ice sheet. And again, my laptop's over here because there's a lot to cover, so I might be looking over there. So the Greenland ice sheet disintegration has already started to happen, and the Greenland ice sheet is the second largest ice sheet in the world. If it were to melt, it would account for a rise in sea level by 7.2 meters, or 23.6 feet. So that's a lot. Right now it's melting at a rate of about 0.7 meters per year, which is a pretty small amount. That's like 0.02 inches, I believe. But most of the melting is occurring at Greenland's surface, which is where a lot of positive feedback loops take place, because as the surface of the sheet melts, then it actually lowers the elevation in which the surface is. And at lower elevations, things are warmer. So that creates a positive feedback loop, because now the areas that are most vulnerable to weather changes and to sunlight and stuff are now at lower elevations than they were before, which means that it's easier for them to melt. Does that make sense? I really wish that I either had a whiteboard or I had good animation skills to help you guys visualize this, because I don't have either of those. I'm sorry. If any of you are good at animation and would like to donate some of your time, I would be very happy. But I don't really have time to work on my skill sets as much as I'd like to, because this is, again, a side gig. Yeah, so that's one of the main ways in which a positive feedback loop occurs through melting for the Greenland ice sheet. Another one is a rise in elevation for a snow line. So the snow line is the lowest point in elevation in which it's cold enough for snowfall to occur and for snow to fall onto the ground. And so as we are warming the planet, the temperatures at elevations are also increasing, which means that you now need to have condensation occur starting at a higher level elevation for snow to fall. So that's also another impact too. And if the Greenland ice sheet doesn't experience as much snowfall, then darker ice will be on the surface of the ice sheet more than white snow. And that matters because of something called an albedo effect. So an albedo is the amount of light reflected by a surface back into the atmosphere. So if you have something like snow, it reflects more light than it absorbs. Hence why you can get sunburnt even in the snow. But if you were to have darker ice instead of a layer of white snow on top, then it will absorb more of the energy instead of reflecting it, which makes the ice melt faster because it warms faster, and therefore also just increasing the overall temperature of the planet. So there is another example of an unfortunate positive feedback loop that we're seeing occur because of less snowfall due to increased temperatures. Now, scientists say that there is a very low chance that the Greenland ice sheet would melt completely, which is good. However, they are already surprised by how fast it is shrinking. So again, that shows that, we can do our best guesses and stuff, and we can do our best modeling, but the Earth is going to do what the Earth is going to do. A similar tipping point to the Greenland ice sheet for the melting section of the tipping points is in the West Antarctic. So now we're going south. If the West Antarctic were to fully melt, it would raise the sea level by 3.3 meters, which is about 10.8 feet. And the biggest problem here for this ice sheet is the decreased rate of snowfall. If the melting rate of the annual snowfall is less than the annual rate of melting for the ice sheet, then that results in more sea level rise, because ice sheets are located in the ocean, so normally the ocean is displaced enough to account for those ice sheets. But if we're seeing more melting than we are seeing growing of the ice sheets, then that could increase sea level. In addition to that, ice sheets also can hold back glaciers from sinking into the ocean. So without that barrier, glaciers would have a huge impact on sea level rise too. And on top of that, on the land, as the land warms, then it starts melting the bottom part of that ice sheet. So it's melting from two different sides. Scientists believe that about a 1.5 to 2 degrees Celsius increase in the Antarctic could cause the ice sheet to reach a tipping point, which means that it would melt faster than we would be able to do anything about it. Keep in mind, when I say a 1.5 to 2 degrees Celsius warming in the poles area, the poles warm faster than the rest of the world. So that's a lot easier of a point to hit faster than for a global increase from 1.5 to 2 degrees Celsius, which we're also on target to hit right now. So we need to stop that. And the last melting tipping point that I want to talk about is the permafrost melt, which is legit out of a horror film when you think about it. Now, permafrost is basically soil that also has ice or frozen organic material within it. Permafrost in general represents about a quarter of the non-glacial covering northern hemisphere. So a lot of the area in the northern hemisphere is permafrost. Some of the biggest areas of permafrost in the north include in Siberia, in Canada, and in the Tibetan Plateau. And then south, near the southern pole, we also see permafrost in the southernmost parts, most notably the southern Alps of New Zealand and of the Antarctic, as well as in Patagonia. This melting represents probably one of the most detrimental potential positive feedback loops, because not only does the permafrost melting just result in sinking of the overall soil, which it's not good, but it can also release greenhouse gases that have been stored in the permafrost for thousands of years. And so we're talking about potentially twice the amount of CO2 that we currently find in our Earth's atmosphere frozen in ice in the permafrost. Not to mention, there's also a bunch of methane, which is a very strong greenhouse gas, stronger than CO2, that is also in the permafrost. Okay, now let's talk about the next category of tipping points, which are biome shifts. So the first biome that we're going to talk about is boreal forests, which are located in the northern parts of North America, Europe, and Asia. Think of, like, in Washington, the pine trees, spruce, and larch. Those are trees that are designed to thrive in colder conditions. Boreal forests are considered the largest terrestrial ecosystems in the world. and they represent about a third of carbon storage on land. And a third of these boreal forests actually sit upon permafrost. So you can see how some tipping points go together. Currently, boreal forest areas are warming twice as fast as the globe, which is extremely problematic because warmer climates bring new pests and diseases to those forests, which they hadn't seen before, weakening the forest in general. Less rainfall and snowpack result in a bigger chance of dry out and massive wildfires, which we've already started to see. In fact, the IPCC notes recently that a 1.5 degrees Celsius increase could result in an increased mortality of trees. So that's another example of a positive feedback loop. Not to mention, wildfires also do release CO2 back into the atmosphere that was being stored in these forests. Now, the northern boreal forests can potentially move further north as the globe warms, moving into the tundra spaces. But that has a downside too, because if they do that, then the tundra spaces won't have as good of an albedo because they will be covered in trees instead of more snowpack. So that would also further increase the warming of the planet. Another biome to focus on is the Amazon. So the Amazon rainforest is the largest rainforest in the world, and it is a very important system for the evaporation and transpiration part of the water cycle. So with a decreased amount in rainfall, which is eventually expected for that part of the globe due to climate change, then we will start to see a major die-off in the Amazon rainforest. Now, that's not even to account for the fact that we are already seeing a 17% deforestation rate of the Amazon. If the area dies, it will die back into a savanna, which is mostly grasslands with just a bit of trees. Now, that obviously will not be sustainable for the current organisms that depend on a rainforest environment. And also, it would decrease significantly the amount of carbon storage capable for that area, which we desperately need to maintain. It is predicted that if the globe warms about 3 to 4 degrees Celsius, then that ecosystem could fully break down. And that's all assuming if deforestation doesn't break it down first, which is why it's really important that we maintain no more than a 20% deforestation in the Amazon for the Amazon to survive, which I would recommend less than 20%, but anyways. The last biome shift that we're going to talk about is the coral reef system. Now, coral reefs are the foundation for some of the most diverse ecosystems in the ocean. And because of that, they are extremely important to the foundation of a lot of species. But in addition to that, coral reefs also stabilize the coastal areas and protect them from storm surge, and they provide important fishery and tourism opportunities for coastal communities. Now, coral reefs themselves are made up of two main organisms. There's the coral themselves, which, yes, they are an animal. Then there are these little photosynthetic organisms called zooxanthellae. The zooxanthellae live inside the coral and photosynthesize, which helps feed the coral. When the ocean warms, the coral expels the zooxanthellae because they think that they are intruders. They get confused. The zooxanthellae was their main source of food. So, and also the main source of color, which is why you see coral bleaching. That's when they basically got rid of those little organisms. And as a result, the coral is very likely to starve. And we are seeing this happen at an alarming rate all around the world. Scientists have found that coral bleaching is now 5 times more common than it used to be just 40 years ago. In addition to the warming oceans, coral reefs are also being impacted by overfishing and destructive fishing practices, storm surges, ocean acidification, chemical and sediment runoff, sea level rise, and also shifts in the ocean circulation, which we'll get more into in a sec. So coral reefs themselves, they can recover if given the opportunity, but the window of that survival is closing as the ocean continues to heat up. Scientists predict that a 1.5 degree Celsius warming, which we are easily about to hit, could result in 70 to 90% of the coral reefs in the world dying. And that one also keeps me up at night because that one just kills me. Okay, the final category of tipping points for the planet that we're going to look at are circulation, like the global circulation. So the first one that we're going to look at is the Atlantic Meridional Overturning Circulation, also called AMOC. So the process of the Atlantic Ocean brings warm water from the Gulf of Mexico all the way up to Europe. That is possibly in jeopardy primarily due to an influx of fresh water from increased rainfall in certain areas and melting of glaciers and ice sheets. Scientists have already found that the AMOC has weakened by 15% since about the 1950s. And when the AMOC weakens, it kind of creates a positive feedback loop for itself. Circulation itself brings salty water into a high latitude Atlantic, and the salty water increases in density. And so we can say the water is able to sink because it is salty, and it is salty because there is this circulation. It's like a self-reinforcing system. So scientists are not really sure how much warming will cause the AMOC to fully weaken, because it would most likely be an irreversible change. So then there's the West African monsoon, which climate change could either increase or decrease the rainfall of. Either way, it would be a drastic change in the regional climate for sure, and would also impact the rest of the global climate. And similarly is the third one, which is the Indian monsoon season, which will also be impacted severely one way or another by climate change. Now, those last three, I obviously went through those pretty fast because one, I'm tired and depressed, and two, I get confused with the whole circulation system and stuff, but those are some of the tipping points that we have to worry about. So when people talk about climatic tipping points, those are the 9 that they're most likely referring to. Now I want to get into some positive tipping points. What? Well, potentially, with climate action, there are some positive tipping points to look forward to if we move them in the right direction. One we've already seen in the US specifically, which is when renewable energy, specifically solar power, became a cheaper form of energy than fossil fuel for the first time ever in 2019. Another tipping point that we are looking forward to seeing soon, hopefully, is when electric vehicles become a cheaper option than fossil fuel emitting vehicles. And that primarily revolves around actions taken by China, the EU, and California. They represent over half of car sales, who all do have their own decarbonization plans. So it kind of just depends. What tipping points do we want to hit? Let's hit the good ones. So I hope this made sense. I know it was another big video. I do them every week, it seems. If you have any ideas for a lighter video or one that would require a little less research, let me know. But with all that being said, I hope you have a great rest of your day. Try not to get bogged down too much by the content of this video, because again, we are moving in the right direction for several trends. We just need to move faster. Remember to support your local news organizations and to talk about the climate every single day. Talking about the climate is one of the biggest ways that you could help positively impact the world. And with that, that's all I have. I will see you all on Thursday for the Climate Book Club, where we're reading chapters 7 and 8, I think. I look forward to seeing you then. Bye.